So this section is solving equations containing rational expressions. First off, a definition for us. A rational equation is just an equation that has one or more rational expressions in it. First thing we need to figure out is, are there any values that x cannot be? And in our case, x can't be 2, because that would make this denominator 0, and you can't have a 0 in your denominator. Once we take care of that, just like when we had equations with fractions before, if you multiply both sides by your common denominator, it's okay because you're multiplying both sides by the same thing. In our case, our common denominator is going to be 10 times x minus 2. So on the left side, this 5 and this 10 will cancel, and we'll be left with a 2 in our numerator. So we'll have the original 2 times our x minus 2. And then this x minus 2 will cancel with that x minus 2, and we're left with 5 times 10. And on the right side, these 10s will cancel, so we're left with 29 times x minus 2. And now we'll just simplify or solve this like we have been all year. So 4 times x minus 2 plus 50 equals 29x minus 58. And now we have to make sure, was 4 one of the numbers we said x couldn't be? And no, it's not, because x couldn't be 2. So here's our answer. If you wanted to check your work, you could plug that into the original and make sure you get the same thing. Alright, on this one, first off, notice we can factor into x minus 2, x plus 2, and you do always want to start by factoring. And now let's also notice we can't have x be 2 or negative 2. Those are the two options we cannot get for our answer. So when we find a common denominator, it would actually be x minus 2 times x plus 2. So you have to do that to both sides. Notice on the right side, these will cancel with both, so we're just left with 2x squared. On the left, this x plus 2 will cancel with that x plus 2. So we'll have 3 times x minus 2. And then this x minus 2 will cancel with that one. So 2x times x plus 2. And now we'll just solve this like normal. And let's go ahead and get all these 2x squareds together. And then let's double check, can that be one of our answers? Well, our x couldn't be 2 or negative 2. This is neither. So we are good. Now on this one, notice x cannot be positive 6, because that was what would make our denominator 0. Our common denominator would be x minus 6. So over here, these will cancel, and we're left with 6. Then we'll have 3 times this x minus 6. These will cancel on the right, and we're left with x. Let's check it. Now notice though we said x cannot be 6. So that means this won't work, because if we did use that, our denominator would be 0, which we can't have, which means our answer is actually no solution. And just for vocab, this would be considered an extraneous solution. Alright, with this one, once again, we can see, because of our denominator here, that a cannot be 3. If we had to pick a common denominator, though, it'd be 3 times a minus 3. So over here on the left, this first one, this is a over 1, so nothing's going to cancel. So it's just a times 3 times a minus 3. However, this 2/3, the 3's will cancel, so we're left with 2 times this a minus 3. On the right, both will cancel. Now remember from last chapter, if we had a squared term, in order to solve the equation we'd have to factor, and in order to have it factor, we have to have it equal to 0. So let's go ahead and get this equal to 0 by subtracting our 2a and adding our 12. We can factor a 3 out. And then this will factor into 3 times a minus 2, a minus 1. And now let's check. Were either of those values we couldn't have? No, because we could only not have 3. So both of these work, so there are 2 answers. Now this one, we have to solve for b, but before we can do that, we have to have these so they're not fractions. So once again, we can multiply both sides by our common denominator, which would be ab. So notice in this first fraction, our a's would cancel. We're left with b. In our second one, our b's would cancel. So we're left with a. And now thinking back to chapter 5, in order to do this, we have to get all our b's on the same side. So let's subtract b. And then we can factor a b. And then because this is multiplication, we can divide both sides by that a minus 1. We did already talk about extraneous solutions, but here's the formal definition. And our last problem. So we still want to solve for b, so let's start by multiplying both sides by our common denominator, which would be a plus b. And now we need to get our b's on the same side. Factor out our b. And then we can divide both sides by this 2a minus h. And this is the end of the section.